Okay guys, welcome back to part 2 of permutation and combination video. And in the first part 1 we were looking at how we would arrange, or the number of ways to arrange the letters of the word maximum. This word maximum, okay, the word maximum. Okay, so we're looking at the identical objects where we have what m, triple m's, which are what identical, m, and another m. So how do we what find the number of ways these letters can be arranged? So since we have an identical element, our new case for what? Our new case for n permutation r is just going to be n factorial over what? P factorial over p factorial, where the p is the number of identical objects. Please pardon my writing. Since you can hear it, then it means you can do it. Where the p is the number of what? Identical objects. What do I mean by that? Now let me explain. The p is now going to be what? 3. Why? Because I have here first n, second n, third n. So my n's are what? 3. Therefore my p is what? 3. And then my n is the number of letters in the word maximum. So I have 1, 2, 3, 4, 5, 6, 7. So my n is 7 and my p is 7. No, my n is 7 and my p is what? 3. So how do I find the number of ways the letters in the word maximum be arranged? Will now be what? Will now be 7 factorial over what? 3 factorial. And 7 factorial over 3 factorial. And just take off my board. 7 factorial over 3 factorial will just be 7 times 6 times 5 times 4 times 3 factorial over what? 3 factorial. Then what? I will cancel out my factorial. 3 factorial will cancel out 3 factorial. So I'll be left with what? 7 times 6 times 5 times 4. I take my calculator and I punch it. Where's my calculator? Can't even find my calculator. And I punch it, I should get something 840 ways. Okay guys, this is the case 1. So this one we have only m's being identical. In other ways, in other letters, in other words, in other objects, we might get more than one object being identical and different. For example, if I have 3 m's and 3 c's in the same word, or double m and 2 e's in the same word. So how do we tackle those ones? And those ones will be what? The case 2 of the permutation case. So this is case 1. For example, let me give you an example to try. Let me give you an example to try. You can find the number of ways the word, let me look for a word for you. The number of ways the word m, I, m, e be arranged. So m, I, m, e. How do you do? This is an example for you to try. M, I, m, e. In how many ways can the letters of the word m, I, m, e be arranged? Okay, so you have 2 m's here, and that's very simple for you. And you know that your p is what? The m. So these letters are what? 1, 2, 3, 4. So you are going to get something like what? 4 factorial over the m's are 2, so 2 factorial. That should give you 4 times 3 times 2 factorial over what? 2 factorial. Then you get that the 2 factorials will cancel, and you are left with what? 4 times what? 3, which will give you what? 12 ways. So 12 ways of what? Arranging the letters. Sorry, that should be 4 times 3. That will give what? 12 ways of arranging the letters of the word this. Are you okay? Okay. So guys, let's jump straight into what? The next case, which is what? The case 2, where we have what? Double identical element, or 2 identical element. I'm chopping off my board. This, if you have any question, you can put it in the comment section below. So we have case 2. Sorry. Case 2. Case 2. Here, you want to see if you have what? A double identical elements. For example, when we have the word parallel. Okay. So in how many ways can the letters of this word parallel be what? Arranged. Okay. What are we seeing here? I can see so many things here. First, I can see that I have 3 L's, and I also have what? 2 A's. So I'll write them down. My L's are 3, and my A's are 2. Therefore, in a double case like this, we say that our permutation is what? N factorial over what? P factorial, and then R factorial, where we know the P already. When you have one element being identical, then the R is the other element. So if I have L's being the P, then my A's are the R. Please, are we okay? So that's just it. So if I have different type of elements or letters in the same word which are identical, I will just be multiplying what? The number by what? The factorial. So that continues to be what? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 letters. N is 8. My P is L. The L is what? 3. So 3 factorial times, and I have my A's are 2, so I have 2 factorial, and that should give me, I can just call this all these things on a calculator. Now you know how to find the factorial, so that should give us 3360. 3360. So that's what we are trying to say. So in the next case, in the third case, what we are trying to look at is this. In the third case, it will be like this. The third case, case 3, where you have what? More than what? 3 elements. For, let's say, for example, the word commission. Commission. I-S-S-I-O-N. So you have more than what? 2 letters being identical. You have MM, you have II, and you have XX. So these ones are just going to be in the same format, and we are going to get the same thing in the same format. Let me just take this one here. You are going to get the same thing, the word commission. So you are going to get your M's to be 2, your I's to be 2, and then your S's to be 2. So you are just going to get N factorial over P factorial R factorial times what? Q factorial. So we have a word which have other letters which are what? Being identical. You still multiply by the denominator by that factorial, and that's what we are doing all this while. So please, let's solve the case 2. Let's continue the case 2 in the next video. Then we'll solve more examples to clarify some stuffs. Are we okay? So let's meet in the next video, and then we'll continue with case 3 and then solve more examples. Then you'll be okay with it. Alright guys, thank you for watching, and see you in part 3. Okay, take care.